Hello, math magicians. Today we are going to use the Pythagorean theorem converse, and we're going to classify triangles. So let's recall what classify means. Classify means, oh, it's a right triangle. Oh, it's an obtuse triangle. Oh, it's an acute triangle. So that's what classifying it, giving it a particular putting it in a category. So looking at example A here, we are given two side lengths of a triangle. One of them is 5 centimeters and one of them is 8 centimeters. So before we even get to this theorem, we have to understand the nature of triangles. What are the possible lengths of the third side? So the easiest way to do is let's go ahead and check it out. I could have a 5 right here and an 8 right there. So, and this could form a triangle. And it's like this. And we don't know how long that black one is. But we can make some assumptions. So let's see here. What if I put 8 here, and instead of having a right angle right there, what if I just opened it up all the way? So it's flat. Notice this is not a triangle. It's not a triangle. It's just a segment. It's two segments connected. So how long is that if I were to open it all the way up? Is going to be 13. But it's not a triangle. However, we know that we could have almost opened it up. So it looks like this. Slight angle there, like so. So notice that my black, it's very, 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 very long, very like a sliver. The biggest it could be is almost 13. So 13 is biggest, and yet it can't ever get that big. Can't ever get that big. So if I call my black side x, then x has to be less than 13. So it could be 12.9. It could be 12. It could be 11. Now if I consider taking my two sides, my red here, and I take the 8 and I put it effectively closing it like this, and here would be a diagram that shows almost that happening, like so, and then I make the angle very tight like that. So again, it's a sliver, but notice where my black is this time. My black is extremely small, as opposed to being over here, where it was the longest. So I stretched it out like a rubber band, or I squashed it down over here. So the possibility is, if I were looking at this situation, if the blue is 8 and the red is 5, then the black here has to be 3. But notice that if it is a 3, it's not a triangle. Not a triangle. So what are my possible options? What are my possible options? My side length has to be bigger than 3, 3.1, 3.2, 4, 5, 6, 7, 8, 9, 10, but less than 13. Again, where did those two numbers come from? What I just did was b minus a here, and over here was b plus a. And notice here, this has got to be a positive number right here. So I just took the larger number, subtracted the smaller. It doesn't have to be a, b. Those have to be switched, but effectively, notice what I'm doing. And I'll just go ahead and put that. It's absolute value, because I can't have a negative distance. Let's take a gander at this example right here. We're just going to decide if we can even find these ones form a triangle. And here's what we have to conclude. In order to make a triangle, any two sides must sum to be greater than the third. And it actually never matters which two sides you choose, but you do have to check them all. What I like to do is actually just check the smallest sides. And make it bigger than the largest. So the smallest two add up to be larger than the smaller. So let's take a gander here. I know it sounds a little bit confusing, but here are my smaller two sides. 4 plus 3. When you add those together, you get 7. How does that compare to 5? So clearly we see that here we have a greater situation. So since the two smaller sides add up to be greater than 5, this does make a triangle. Does make a triangle. So how about number 2? The easiest way to do is just to check the smaller two sides. 5 plus 6 is 11. And how does that compare to 7? Well, it's greater. So since it's greater, we have a triangle. What about number 5? In this case, when you add up the two smaller numbers, the two smaller sides, how does it compare to the third? Well, it's actually equal. So what we end up getting is a situation that looks like this, where we have sort of like a drawbridge situation, and it's not a triangle because they're equal.